So as promised in class, here we are going to make a video for the Chapter 12 practice test. This is going to be just like your test. I'm going to try and get 12 to 13-ish questions, and we will have an A schedule for this, so you'll usually have plenty of time to finish this. Okay, so let's jump in. For 1 through 3, determine if it's arithmetic, geometric, or neither. So looking at number 1. We have something that's constant. If I wanted to write out this sequence, it would be the first term is 7, then 11, then 15, then so on. It's going up 4 or adding 4 each time, so this is arithmetic. So for arithmetic, find the common difference and the sum of the first n terms. So the first term, a sub 1 equals 7. The common difference is 4. As we can see, 7 to 11, 11 to 15, 15 to 19. It's going up 4 each time. And then we go to our sum formula. I will be providing these formulas. I kind of know them off the top of my head. You can do it a little faster. So the sum of the first n terms for a arithmetic sequence is n over 2 times a sub 1, which is 7, plus a sub n, which is 4n plus 3. So if I do a little adding, I get this is n over 2 times 7 plus 3 is 10, so 4n plus 10, or, just to simplify it one more time, divide both those by 2, you get 2n plus 5. So that's the first one. Second one, if we look at this pattern, 5, negative 5 thirds, 5 ninths, negative 5 over 27ths. The first term is 5. And this is being multiplied, so this is geometric. And the common ratio is, well, it's going switching signs, so it's going to be negative. And 1/3, 1/9, 1/27th. So it's changing by 1/3 every single time. So now we go to the formula sheet. What's the sum of the first n terms? Well, the sum of the first n terms for a geometric sequence, or series in this case, is the first term, a sub 1, times 1 minus negative 1/3 to the n, 1 minus r to the n, over 1 minus r, which is negative 1/3. So this is plus plus. I have 5 times 1 minus negative 1/3 to the n, over 1 plus 1/3 is 4/3. So if I wanted to simplify this, I'd multiply by the reciprocal, which is 3/4. So we get 5 times 3 is 15/4 times 1 minus a negative 1/3 to the n. So that's our sum. Last one, for 3. This sequence is 2 over 3, then 3 over 4, then 4 over 5, then 5 over 6. If we did 3/4 minus 2/3 versus 4/5 minus 3/4, that's not constant. So this is not arithmetic. So is it multiplied by a common ratio? 2/3, then 3/4, then 4/5. So it's not geometric, because if we wanted to find the common ratio, 3/4 divided by 2/3 is not equal to 4/5 divided by 3/4. Those aren't the same, so it's not geometric. So this one we would write neither. Moving on to the next section. So for 4, 5, and 6, it asks us, write out the sum of each, find the sum for each. So we go to our sum sheet. First, if we have any constant, we can factor that out. So that's the sum, 3 times the sum from k equals 1 to 50 of k. So looking at our formula, the formula is n times n plus 1 over 2. So our n is 50. So this is 3 times 50, 50 plus 1, all over 2. So now I'm just going to plug into my calculator. If I plug this in, I get 3,825. So that's my sum. Next one. From 1 to 30, find the sum from 1 to 30 of k squared. Well, I look at my formula. My formula is n times n plus 1 times 2n plus 1 all over 6. So now I just plug in. I have 30 times 30 plus 1 times 2 times 30 plus 1 all over 6. I don't have to do anything else. Type that into my calculator. I get 9,455. Hopefully for these problems it's okay if I don't show you what I'm typing into the calculator. For the next one I will. So this isn't one of our formulas that we had from section 4.1. This is a geometric sequence. So we need to know what a sub 1 is, which it's 1/3. Plug in 1, we get 1/3. And now we just go to our formula. The sum of the first 7 terms is 1/3 times 1 minus 1/3 to the 7th all over 1 minus 1/3. That's our formula. So our sum is equal to 1/3, 1 minus 1/3 to the 7th all over 2/3. If I do a little simplification before I type this in, I get 1/3 divided by 2/3 is 1/2 times 1 minus 1/3 to the 7th. And for you guys, we'll just show the calculator off. We'll go down here. What we want to type in is 1/2, so 1/2, then parentheses. And just to be safe, I always put times. 1/2 times 1 minus parentheses 1/3 to the 7th. I hit enter. My calculator gives me a fraction right away. I get 1,093 over 2187. And if I wanted a decimal, I can hit Control Enter and I get 0.4998 if I go to 4 decimals, or 1,093 over 2187. Either one of these I'll take for your answer. Moving on. Let's finish 7 and 8 on this page. Find the 95th term. This is an arithmetic sequence. So if I want a of 95, we should know this formula. It's a sub 1 plus n minus 1 times d. So a of 95 equals 3 plus 95 minus 1 times the difference, which is 4. So this is 3 plus 94 times 4, which is 379. These should be relatively easy and you can do pretty quickly. Same thing. Find the 11th term of, this is a geometric sequence, so a11 equals, I'll write out the formula for you, a sub 1 times r to the n minus 1. So here, my first term is 1. The common ratio is 2 each time, and that would be 11 minus 1. So that's 2 to the 10th, which is 1,024. Let's move on to the second page. So for a problem like number 9, it says find the general formula of the arithmetic sequence. And they give us the 7th term and they give us the 20th term. So what we're going to do is we're going to come up with 2 equations to solve this. So we have a of 7, which is 31, equals a sub 1 plus n minus 1, so 7 minus 1, times the difference. And likewise, we have a sub 20, or the 20th term, which is 96, is a sub 1 plus 20 minus 1 times the difference. We have 2 equations, 2 unknowns. So 31 equals a sub 1 plus 6d. And we have 96 equals a sub 1 plus 19d. If I just subtract these two, I'm going to subtract the first one from the second. I get 65 equals, the a sub 1's cancel, and I'm left with 13d. So that means my difference is 5. Now to find the first term, I plug that back in. So 31 equals a sub 1 plus 6 times 5, So 31 equals a sub 1 plus 30, or a sub 1 equals 1. Awesome. So now I can come up with the equation. So a sub n, any term, equals 1 plus n minus 1 times d, which is our difference. So if I want to just simplify this algebraically, that's 5n minus 5. Minus 5 plus 1 is negative 4, so 5n minus 4 is our general formula for this equation. Moving on. Number 10, determine if the following infinite geometric series converges. So if an infinite geometric series converges, we want the absolute value of the ratio to be less than 1. So let's look at this first term. So first term is 3. It's decreasing, or the rate is being multiplied by 1/3 every single time. 1/3 is less than 1, so this converges. Okay. How do we find the sum? Well, our sum of our infinite series is the first term over 1 minus r. So this is 3 over 2/3, which is 9/2. So if I add up all of these terms, it's getting closer and closer and closer to 9/2. We can do the exact same thing for b. Our first term, if I plug in 1, is 5. My r is what's inside here, so negative 5/4. If I look here, the absolute value of r is greater than 1. Because this is greater than 1, I stop. I can write this is a divergent series. Likewise for c. My first term is 3. My ratio is what's on the inside, so 1/2. So then I just plug in to my formula. My sum is 3 over 1 minus 1/2, which is 3 over 1/2, which is 6. So if I add up all of these terms, I'm getting closer and closer to 6. All right, the last two are partial fraction problems, so I'm going to do each one of those separately. So first, number 11. Write out the partial fraction decomposition. So I first look at this and go, can I break these down anymore? Nope. These are all linear terms, so I can write a over x, that's my first one, plus b over x squared, that takes care of the x squareds, plus c over x minus 1. Step 2, clear the fraction. We're going to multiply everything through by x squared minus x. So on the left, I am left with x minus 4 equals a times x minus 1. One of the x's cancel, so I'm just, instead of x squared, I'm left with x. Next one, both of the x squareds cancel, so it's b times x minus 1 plus c, the x minus 1 cancels, times x squared. Now if I do a little math here, don't have to do a lot, I get a x squared minus x plus b times x minus 1 plus c x squared. All right, now's the grouping part. So I look, how many x squareds on the left side? 0. Equals. How many of these have x squareds on the right? A plus c. How many x's do I have? What's the coefficient of the x on the left side? 1 equals negative a plus b. So that takes care of that term, that term. Last one, negative 4 equals negative b. Now I could go type this into my calculator, but I know that negative 4 equals negative b, so b has to be 4. I can solve that easily. Then I look here, the second one, I have 1 equals negative a plus 4. So I subtract 4 from both sides. I get negative 3 equals negative a, or a equals 3. So that one's not that bad to solve by hand. So the last one, I have 0 equals 3 plus c. So c equals negative 3. So that one's not that bad to solve. I can solve this one by hand pretty easily. So I'm going to plug those back in at the top to finish the problem out. I'm left with 3 over x plus 4 over x squared plus negative 3 over x minus 1. This is my partial fraction decomposition. So the last one is a little more complicated, but it's nothing that we can't handle. So the last problem on the back, number 12. Again, partial fraction decomposition. First thing I want to see, can I factor this at all? I can't factor x squared plus 4, so I leave that. I can, however, factor x squared minus 1. That's x plus 1, x minus 1. That's the difference of two perfect squares. So now, my first term is an irreducible quadratic. So that's ax plus b over x squared plus 4 plus, my second term is linear, so it's just c over x plus 1. And then the last one, d over x minus 1. So that's the first step. Step 2, clear the fraction. If I clear the fraction, I'm left with 4 equals ax plus b times x plus 1, x minus 1, which we've already multiplied out is x squared minus 1. Next one, if the x plus 1's cancel, then I'm left with c times x squared plus 4 times x minus 1. Likewise, with d, I'm left with x squared plus 4 times x plus 1. Okay, I suggest you do a little algebra here. If we FOIL this out, we get x cubed plus x squared, x cubed minus x squared plus 4x minus 4. And here we get x cubed plus x squared plus 4x plus 4. Okay. Last but not least, FOIL this out. So I have ax times x squared, so ax cubed, ax minus ax plus bx squared minus b. And then I'm just going to write these last ones, plus c x cubed minus x squared plus 4x minus 4 plus d times x cubed plus x squared plus 4x plus 4. All right, now's the time we do our grouping. We're going to have 4 equations. So I have 0x cubes on the left, so 0 equals. I have ax cubed. I don't have a bx cubed. I have a cx cubed, so plus c, and I have a dx cubed, plus d. Next ones, so I'm going to cancel those out. X cubed, x cubed, x cubed. Next, x squareds. I have 0 x squareds. So these are my x cubes. These are my x squareds. I'm just going to write those to the side. X squareds. I don't have any ax's. I have 1 bx. I have negative c. So those go. And I have plus d. Then I have my x terms. So I have 0 on the left-hand side equals negative a. There's that. Plus 4c. There's that. Plus 4d. Last is just my number. So I have 4 equals negative b minus 4c plus 4d. So we're going to solve using matrices. And what we want to type in is we want the A inverse times B. So our matrix is going to be a 4 by 4. And we just take the coefficients right here. So our matrix should be 1, 0, 1, 1. 0, 1, negative 1, 1. -1, 0, 4, 4, and 0, -1, -4, 4. And our b invert, so that's inverse times b, which is 0, 0, 0, 4. So typing this into our calculator, I'm assuming that you know how to do that. If not, you can ask me for help. Once you type this in, we get a solution set that says a equals 0, b equals -4 fifths, c equals -2 fifths, and d equals 2 fifths. So to finish this off, we're going to write all of those in there. So my partial fraction of x squared plus 4 times x plus 1, x minus 1 is equal to -4 fifths, 0x plus -4 fifths all over x squared plus 4 plus -2 fifths over x plus 1 plus 2 fifths over x minus 1. That's your answer. Please let me know or email me if you have any questions. If you need any more clarifications, you can always stop by before school or after school. Good luck. Test on Thursday.